All right, so let's get started. Hello, everyone, and welcome. So first up, I would like to thank you all for making the effort to get out here. I know it can be quite a challenge to attend so many different sessions across multiple locations, so really appreciated you guys coming out here to attend this particular session. We've got a lot of good things to talk about, so hopefully it'll be worth your time. My name is Sid Gupta, and I'm a Senior Product Manager at AWS Config. And today I'm going to be talking about how you can use AWS management tools to enable governance, compliance, operational, and risk auditing in your cloud environment. So here's what you can expect from this session. I'll spend a few minutes talking about what is meant by governance and compliance, and what's needed to successfully enable them in an enterprise. I'll describe some of the challenges faced by enterprises today in enforcing governance and how AWS management tools can help you overcome those challenges. I'll also walk through some key governance use cases and give you some demos along the way. And in the end, we can have a Q&A session. We've got a lot to cover in the next 60 minutes, so let's get started. What is meant by governance and compliance? Governance, in the broad sense, is an oversight role and the process by which companies manage and mitigate business risks. So in the case of IT, it puts structure around how organizations can align IT strategy with business strategy. Compliance, on the other hand, ensures that an organization has all the processes and controls in place to meet the requirements set forth by a governance body. Now let's look at what's needed to successfully enable them in the cloud. So in order to achieve your governance and compliance goals, you need to define what IT is supposed to do. You need to discover what IT resources exist in your cloud. And then you need visibility into your cloud environment. So you need to monitor what IT is doing. And finally, you need the capability to respond to changes, such as non-compliant events, etc. But the key challenge that most IT enterprises face today is that governance is oftentimes perceived as a roadblock to innovation and agility. So your employees end up bypassing these controls and processes, resulting in what's commonly known as shadow IT. For example, in the case of one customer, every EC2 provisioning request went through an approval process in order to make sure that they're not using an EC2 instance which is super large in size, or if they're not using an AMI that's on an approved list. In another example, all cloud provisioning requests went through a change control board, which is very typical in an on-premise environment. But that resulted in impacting the developer productivity, which in turn impacted the business. But it doesn't have to be that way. AWS enables you to do both, enforce governance, as well as keep up the productivity of your developers in today's dynamic environment. By using our suite of management tools, you can transform your IT department from a cost center to an innovation center. So in the next few slides, I'll introduce you to a suite of management tools using which you can enforce governance and verify compliance against best practices without compromising on the developer agility or innovation. Now let's look at two tools that can help you define your cloud environment and enable self-service: AWS Cloud Formation and Service Catalog. So let's say that as an IT administrator, I want to allow my developers to provision resources in the cloud, but at the same time, I want to ensure that they provision the resources in an orderly and a predictable fashion. So for example, if I'm building applications that process credit card holder information, I want to make sure that every new application stack that comes up in my environment complies with PCI DSS regulations. So in order to make that possible, I need to define the infrastructure and its configuration in the form of a blueprint that can then be used by my developers to spin up new environments in the cloud. So AWS Cloud Formation is a service which is meant for that exact purpose. It gives you an easy way to define that blueprint in the form of a template, which can be written in YAML or JSON. And then you can define the resources that need to be provisioned, as well as its configuration. And Cloud Formation will go ahead and create a stack containing those resources. You can then manage that stack as a whole via the template. So if you want to update or delete certain resources, you just need to update the underlying template. So it's an easy way to manage your resources. Now let's see how you can add additional governance on top of Cloud Formation. Let's consider the use case where, as an IT administrator, I want to help my employees to quickly find approved IT services in the enterprise. So for example, I want to give my end users the ability to provision resources in the cloud, but I don't want to give them access to the Cloud Formation console or let's say the EC2 console. I want to limit their AWS IAM role permissions to a bare minimum for governance perspective. So in such situations, I need a service that allows me to create a catalog of products which can then be accessed by anyone in your organization, which uses a Cloud Formation template under the covers with appropriate constraints that I have defined as an administrator. So AWS Service Catalog is one such service that allows organizations to create and manage catalogs of IT services that are approved for use on AWS. So these IT services can include anything from spinning up virtual machines to databases to multi-tier application architectures. Let me show you how this works. So in this demo, as a Service Catalog administrator, I will offer a product in the Service Catalog that allows my marketing team to spin up a WordPress website in a self-service manner without giving each user access to the EC2 console or the Cloud Formation console. Okay, so let's go to the Service Catalog console. The first thing that you'll see here is you need to create a portfolio. So a portfolio is an easy way to manage products in your Service Catalog. So for example, I'll create a portfolio here called Cloud Services. You can provide some details about who's the owner. So I created a portfolio. So now I need to add products in that portfolio. So let me go ahead and add a product in that portfolio. I can provide some details, like in this case, it's a WordPress website. And now this is where, as an administrator, I can upload the Cloud Formation template that would actually provision the resources for this WordPress website. So let me go ahead and upload a template. Let's review that and go ahead and create a product. Okay, so now I have a portfolio, I have a product. Now let me add some constraints from a governance perspective. So there are basically three types of constraints launch constraint, notification constraint, and template constraint. Now, launch constraint allows you to assign an IAM role to the product, which is used to provision the resources in that product. So this allows you to, for example, restrict the IAM permissions of your end users to a bare minimum. So for example, in this case, I will let my marketing department access only to the service catalog and not to the EC2 console or the CloudFormation console. But the product needs those capabilities to spin up EC2 instances as well as access to the CloudFormation. So I can define a role here that my product would use. So in this way, I'm not impacting the permissions or the roles of my end users. The notification constraint allows you to stream notifications to an Amazon SNS topic. And the template constraint allows you to limit the options that an end user can see when he's requesting a product. So let me go ahead and add a launch constraint for this demo. I'll assign an IAM role that I have previously created for this WordPress product. And this IAM role only has permissions to spin up EC2 instances and access to the CloudFormation stacks. Go ahead and create that. All right, so now I have defined a constraint. Now I can provide access to the users, so I can share this product with different groups or roles in my organization. So in this case, I will share this product with folks in marketing. And then I can also share this product with other accounts in my enterprise. So this is an easy way to make a product accessible throughout your enterprise. So for the sake of this demo, I'll skip that part. Just go ahead and create the product. So that completes the admin setup for this catalog. Now let's log in as an end user. So in this case, a marketing user, and let's see what he can see in the service catalog. So I'll log in as a product marketing user. So as you can see in the service catalog, I cannot see any administrative options here like creating a product. All I can see is a dashboard and the products that have been made available to me by my administrator. So I'll go ahead and I see that a WordPress product is there. I'll go ahead and launch that. Provide some basic details. And I'll just enter some details that are coming from the CloudFormation template in this case, like the database username and password that I need for my WordPress website. And then I have to select the instance type. So in this case, I have various options to choose instances all the way from micro to 8XL. And this is because my admin did not put any constraint on the template. So for governance perspective, if I had put a template constraint, I could restrict that size to be maybe a small, medium, or a large instance. So from a cost saving perspective, I could introduce that additional constraint as well. But for this one, I'll be a disciplined user and just select a medium-sized instance here. And go ahead and hit next and launch this product. So while that's being created, underneath the covers, a CloudFormation stack is being created with EC2 instance backed by an EBS volume and a MySQL database. So all that has been configured by my administrator. Now let me just go and try to access the CloudFormation console or the EC2 console just to show you that I have limited permissions as a marketing user. So I'll try to access the CloudFormation console. And you'll see that I'm not authorized to do any or take any action on the CloudFormation console. Similarly, if I go to the EC2 console, I would not have any authorization to do anything. Okay. So in this way, my administrator was able to restrict my access as an end user to just the service catalog. So I got what I wanted, which is a WordPress website. But at the same time, my administrator was able to enforce governance by limiting my access to the appropriate consoles. So let's go back and check if the WordPress site is up and running. So that's the website URL. And that's my WordPress site. Okay. So that was a real quick demo on how to use Service Catalog and CloudFormation self-service. Okay. So just to recap, so far I've shown you 2 tools that can help you define how users can provision resources in the cloud. Now let's look at some tools that can help you gain visibility into the cloud so that you can enforce proper governance. So AWS Cloud Trail and AWS Config are 2 such services. AWS Cloud Trail is a service that records API calls that are made on your account. It is a crucial service because it maintains an audit trail of all API activities carried out by various users in your account. This audit trail is necessary for troubleshooting purposes as well as audit and compliance reasons. You can use CloudTrail to gain visibility into the use of root credentials or to detect who is accessing your sensitive data. For example, the source IP addresses. Let's take a look at another service, AWS Config, which is really important from a visibility perspective. So AWS Config is a service that continuously records the configuration of your resources, and then it allows you to evaluate those recorded configurations with desired configurations. So for example, by continuously recording the configuration of your EC2 security groups, you can see how its configuration changed over time. Now, that information can be really useful for troubleshooting purposes as well as root cause analysis, especially after a security breach. You can then use config rules to define that desired configuration. So in this case, let's say port 22 or SSH should not be accessible from outside your corporate network. So AWS Config will then compare that recorded configuration with this desired configuration, and it will then alert you if any particular resource does not comply with that desired configuration state. This information can also be accessed programmatically, so you can consume them into your systems of record or operational tools. Now let's see how you can use these tools to enable governance. Have you ever wondered if there are any S3 buckets in your enterprise that have public write access, or any buckets containing sensitive information that are publicly readable? Well, you're not alone. This is a topic of grave concern for most enterprises today, and I'll show you how you can use AWS Config to instantly identify buckets that are world writable or world readable. So in this demo, I'm going to be using a combination of management tools. So I'll use CloudFormation stack sets to provision a config rule across multiple accounts. I'll then use a config rule to identify the S3 buckets that are world writable, and then I'll use CloudTrail to view the actual API events. Okay, so let's go to the CloudFormation console. Let's do stack sets. So stack sets is a relatively new feature in CloudFormation, and it basically allows you to take a CloudFormation template and then deploy it across multiple accounts and regions. So if you want to ever turn on config across accounts and regions, you could do that via the CloudFormation template. If you want to turn on a particular config rule, it's an easy way to do it through stack sets. Go back. Okay, so let me go ahead and create a stack set. So out of the box, there are a few templates that are available in stack sets, like to enable config or a few config rules. So let me go ahead and just upload my own template for identifying S3 buckets that are world writable. I'll just leave the default parameters. So that's the name of the rule, S3 bucket public write prohibited. And this is where I would specify the accounts where I need to turn on this rule. So I could either enter the account numbers or upload a file containing the accounts. Or the third option, if you're an AWS Organizations customer, you just need to provide the organization unit ID, and stack sets would go ahead and retrieve all the accounts that belong to that organization unit and deploy the stack in those accounts. For those of you who are not familiar with AWS Organizations, it's a service that lets you organize different accounts hierarchically in the form of an organization unit. So if you have different business units in your enterprise, you could mimic that structure in AWS Organization and associate all the accounts to those organization units. So it's an easy way to manage multiple accounts in your enterprise. So I've created an organization unit previously, so let me just go ahead and enter that here. I'll now specify the regions where I want to deploy this stack. So I'll just select one region for now. And I have a few additional deployment options, things like maximum concurrency. So if I'm deploying across multiple accounts, do I deploy it concurrently or sequentially? As well as the failure tolerance. So if for some reason I encounter an error while deploying the stack in a particular account, should I pause the deployment into the other accounts, or should I roll forward? So I'll go ahead and hit next. Skip that. Okay, so just review this information. As you can see, there's the account numbers that are listed there. So stack sets took the organization unit ID that I had entered previously, and then it retrieved the accounts that were associated with that organization unit. In this case, I have only 2 accounts tied to that. So there are a total of 2 stacks that need to be deployed. Okay, let's go ahead and create that stack set. Okay, it's running. Let's give it a few minutes. All right, so that succeeded. So at this point, my config rule has been deployed in those 2 accounts. So just real quick, let's go and verify in one of those accounts. And let's go to the config console. All right. So we recently introduced this dashboard in AWS Config. So as I mentioned earlier, Config is a service that is continuously recording changes to the configuration of your resources. So the first thing that it does is it discovers all of the resources in your account in that region. So what you see here on the left side is your resource inventory, so you have the count of all resources by type, and you can drill down further and get a list of all those resources. You can then view the configuration history of a particular resource to see all the configuration changes over time. On the right-hand side, you have the config rule compliance status, so things like how many rules are non-compliant, how many resources are non-compliant, and the top non-compliant rules in your account. So let's go ahead and see if that S3 write prohibited rule got turned on. So I can see that it's turned on, and it has already identified one non-compliant resource. Let's click on that. So that's the name of the bucket. Looks like upcoming releases 2018. Sounds like a pretty sensitive information in there. So that bucket is currently world writable. So I can go ahead and fix that by accessing the S3 console right from the config console. So we click on that link over there on the right. So I go to the S3 console, and I can notice that I have public permissions on this bucket. So let me go ahead and fix that. So I'll remove the write permissions as well as the read permissions on that. Save it. So now let's go back to the config console and see whether config detected that configuration change and marked this bucket as compliant. So let's check that. Let's go to the rules dashboard. So I can see that it is still non-compliant, so let's wait a few seconds. All right, so I can see that the S3 write prohibited rule is now compliant. So config was able to immediately detect that configuration change and run that evaluation against this rule. So if I click on the config timeline for that resource, I can see the configuration history of this resource. So right at the top, you see all the changes that occurred on that particular resource over time. I can view the basic configuration details of that resource, things like the Amazon resource name, the bucket ACLs, etc. And I also noticed that there were 4 events that occurred on November 15th, so let's click on that. So these are the CloudTrail events. So basically, there was a put bucket ACL or a create bucket API call on that bucket. And this information config is pulling from CloudTrail. So on this timeline page, you get to see all the configuration changes as well as the API activities related to that change. So for further details, I could click on the CloudTrail link. And here I can get additional details like the source IP address, the username, the event ID, etc. I can get more details if I click on View Event. So this is additional auditability that you can get using CloudTrail. All of this information is also available in your S3 bucket, so you can access it from there as well. Okay. So I also noticed that there is a change that occurred on November 15th. So let's click on that in config. And so here you can see basically the configuration history. So essentially, it shows you what the permissions on this bucket were previously. So in this case, the bucket had read and write permissions. And then on the right side, that is the latest configuration. And you don't see the read and write permissions anymore. So it's basically config was able to track that configuration change and report it over here. This information is also available programmatically, so you can consume it using our APIs as well. If I scroll down at the bottom, I can also see the CloudTrail event associated with this change. Okay. So now let's look at another popular governance use case from a visibility perspective. The Center for Internet Security, or CIS, has published a set of configuration best practices for AWS, and it serves as a valuable playbook for a lot of security professionals across the globe. So one of the common asks from customers is to find out if their AWS environment is compliant with those CIS recommendations. So let's see how AWS Config can help you with that. So this is the white paper that has been published by CIS. And you can see a bunch of recommendations around IAM best practices. So for example, ensure that MFA is enabled for all IAM users. There's some requirements around password policies for IAM. Enable that CloudTrail is enabled, or ensure that CloudTrail is enabled. Ensure that config is enabled in all regions. Ensure that there are no wide open security groups for SSH, things like that. So let's go to the config dashboard, to the rules, and add a rule. Now, so config has out of the box about 45 different managed rules. These are based on best practices, industry best practices, AWS best practices, as well as CIS benchmarks. So you could choose some of the rules from here. So for example, let me search for MFA. So there is a rule for verifying that the root account has MFA enabled or not. Similarly, let's look for SSH. So this basically detects security groups that are wide open. Let's look for IAM. There are a few, that's a rule on IAM password policy. So these are some of the rules that CIS has recommended. But you won't find all of the rules that CIS recommended in this list yet. So for that purpose, you could create a custom rule. So custom rule is something where you define that evaluation logic in the form of a Lambda function. So you create that Lambda function and you associate it with the config rule over here. And then you can define when to trigger that rule, either periodically or upon configuration changes. And config will then go ahead and run that rule for you. Now, there are about 45 to 50 different recommendations in that CIS white paper. So it would take a lot of effort to create a custom rule for every one of them. Fortunately, our friends in AWS security team have already gone ahead and created a bunch of custom rules and have a CloudFormation template that's available on GitHub. So this CloudFormation template uses a mix of the managed rules as well as the custom config rules. And you can then just run this template in your account and instantly identify all the resources that are non-compliant with the CIS recommendations. So for example, let's scroll down and see these are some of the rules that, the config rules that map to the CIS recommendations. Here are some more. So I've gone ahead and deployed this CloudFormation template in my account. So let's see what we find. So I can see that a bunch of resources in my account are non-compliant, which is not good. You can see here that volumes must be encrypted or security groups must restrict SSH traffic. There are a bunch of resources that are non-compliant. Users must have MFA enabled. So let's look at one of these rules, the IAM password policy. And so in this case, this particular account violates that IAM recommendation from CIS. So now I have a quick way to find out the non-compliant resources in my account. Okay. So a quick recap of what we've done so far. We've looked at how we can implement governance during the provisioning phase using Cloud Formation and Service Catalog. And we've looked at how you can use AWS Config and CloudTrail to improve visibility into your environment. Now let's look at some tools that can help you manage and govern your EC2 instances. So let's say that you want to audit the inventory of software applications that are installed on your instances, and you want to ensure that certain blacklisted applications don't exist on them. So the EC2 Systems Manager inventory service provides visibility into the software catalog and the network configuration of your instances, as well as your on-premise servers. You can also sync this information to a central S3 bucket where you can use Athena as well as QuickSight to get some more insights into your inventory. The State Manager is another service that ensures that your virtual machines are in a consistent state or a desired state. So you can use it to define tasks such as bootstrapping your instances with specific softwares upon startup, or to join it to a Windows domain, or to make sure that your agents are updated on a weekly basis. So in this demo, I'm going to be using State Manager to schedule inventory collection every 30 minutes and update the SSM agent once a week. I'll also set up a config rule to detect FTP software on my instances. Okay. So let's go to the EC2 console. Scroll down to State Manager. Now, we recently announced the AWS Systems Manager. It was just announced yesterday. So that's pretty much the same thing, but it is now accessible through the AWS console separately. So there are basically two entry points at this point, but essentially you would find the same functionality over there as well. So in State Manager, I need to create an association. So an association is basically a way to define the documents that need to be executed. So in order to bring your instance into a desired state. So in this case, a document is basically a set of tasks that need to be carried out. So in this case, gather the software inventory. Out of the box, there are a few documents that are already provided up there, but you could create your own document as well. I then need to define the targets where I need to collect my inventory from. So I'll choose a few instances based on the tag. And then I'll schedule it to run every 30 minutes. And I can also choose what information gets collected for my inventory. So for example, the software applications, my network config, Windows updates, or roles. So I'll just leave the defaults and create an association. All right, so let me create another association to update my SSM agent once a week. Again, there's a document available out of the box, update SSM agent. I'll define my target. And I'll update it once a week, every Sunday at 1 a.m. Create that. Okay. So now let's take a look at the inventory that got collected on one of the instances. You go to the inventory tab. I'll filter on applications. So here's a list of all applications that are installed on my EC2 instance. It's got all the details such as the installation time, the version, etc. And all of this information is synced to AWS Config. So once this information is available in AWS Config, I can then use config rules to analyze this information further and identify any blacklisted applications. So let's go to the config console. And let's create a rule. So in this case, there is a manage rule out of the box for identifying any blacklisted applications. So I'll click on that. And let me just rename it. So in this case, I'm going to be looking for any FTP software on my instances. So I just need to enter the application name in here. Let me go ahead and save that. So now the rule is evaluating, and it has already identified one resource that has that FTP software on it. So you can look at the instance here, and when you click on it, you get, same as before, you get the config timeline for that, all the changes that occurred. And you can see that this was a fresh installation of FTP, so there was no prior value. So this gives you good information about when the software was installed on that instance. Now let's consider another use case where you want to centrally manage secret keys or database connection strings that can be used by our developers, so that they're not stored in any local configuration files, or even worse, in plain text on their laptops. Or let's see another use case where you want to manage the Windows armies centrally and make it easier for your developers to get the latest Windows army. So the parameter store service provides a centralized store to manage data such as database strings or secret access keys, and that can be encrypted using KMS. With parameter store, your information stays within your environment, and you can control access to this information using IAM. It also integrates with CloudTrail, so you have full auditability of who accessed your parameter store. And then the feature that we just announced last week, you can also direct a Cloud Formation template to fetch the template parameters from parameter store. So you don't need to enter sensitive information like usernames or passwords in the Cloud Formation template anymore. You can just refer the parameter store to get that information into your template. These parameters can be easily referenced across AWS services such as Amazon ECS and Lambda, as well as other EC2 Systems Manager services such as Run Command and State Manager. So in this demo, let's retrieve the latest Windows army from the parameter store and use it in a Cloud Formation template to spin up an EC2 instance. Okay, so we go to the Cloud Formation console and create a stack. Okay, I'll give it a name. Now in the parameters, the CloudFormation template parameters, I have this AMI ID. So in this case, instead of actually typing in the ID, the latest AMI ID for Windows, I just need to type in the parameter store namespace. So this information would be used by CloudFormation to query the parameter store and retrieve the latest Windows Army ID. So you don't have to keep track of finding out what's the latest ID for your Windows machines anymore. Parameter store would do that for you. So, sorry. Skip that. All right, so let's move to the next screen. So leave the defaults and go ahead and create that stack. So while that stack is creating, here is the CloudFormation template that I used. So as you can see for the Army ID, I have the type defined, which is a SSM parameter value. So I just need to provide the default value, which is I'll be looking for the latest Windows Server 2016 English Nano base. And that will just help CloudFormation to make that query and get the actual Army ID in return. So let's go ahead and see if our stack got created. So there it is. We have an instance over there. Let's quickly verify the Army ID for that instance. So as you can see here, there is an Army ID, which CloudFormation retrieved from CloudFormation and created an instance for you. So really powerful mechanism to centrally manage your data in the parameter store so that your developers can easily access those parameters centrally. Let's look at a couple more governance use cases. So how do I manage patches on my EC2 instances? Or how do I execute commands on my EC2 instances without requiring my engineers to SSH into the instance? So the Patch Manager service is an automated tool that helps you simplify your patching process. You can scan your instances for any missing patches, and you can automatically install them. You can select the timing for your patch rollouts, as well as control instance reboots, etc. The run command is a tool that lets you run commands or scripts remotely on your EC2 instances or your on-premise virtual servers. You basically use a document to execute that script across virtual machines, and that script gets executed simultaneously, thereby eliminating the need to SSH into each machine. So in this demo, let's view the patches installed on my EC2 instance, and I'll use run command to update a Java application on my Linux instance. Let me quickly scroll down to patch compliance. Select the instance where I want to check the compliance. So I can see all the patches that are installed on my instance over here. I can also filter it by severity level. So for instance, let's look for critical patches. So you can see that information. Now let's go to the run command demo. So in this case, I've got a Java application. Let's just verify the version of the software that I have on my machine. So I have a version 9.112 of Java package installed on my machine. So let's say I want to update this to the latest version, and I want to do it across my EC2 instance fleet. So I'll go to the run command, and I'll create a document. I'll create an association here, run shell script. I'll define my target. So in this case, there are 2 instances here. And then I can define the command that needs to be executed on these machines. So I need to update my Java package. Okay, let's run that. So in this case, run command is executing that command on those 2 virtual machines without actually SSH into those machines. So let's go and look at the output of that command. So here I can see that the command was executed and it was updated to the latest version 1.9115. So let's quickly verify that, and I see that it has been updated to 9.115. So really powerful mechanism to update all of your EC2 instances using a central utility. So quick recap of what we've done so far. We've looked at how services like Cloud Formation and Service Catalog can help you implement governance during the provisioning phase, and how services like Config and CloudTrail help you get more visibility into your cloud environment. We've also seen a suite of services in EC2 Systems Manager that help you manage and govern your EC2 instances. So now let's look at how you can respond to events. So particularly those events that make your resources go non-compliant. So this is possible using Amazon CloudWatch. So CloudWatch Events is a service that allows you to pick events of interest and define some workflows or rules around them. So for example, you could detect an event which stops CloudTrail logging, and then you could create a workflow to start CloudTrail logging. So it's a pretty automated way of handling that. So in this demo, I'll go ahead and create a CloudWatch rule. So let's see here. I'm going to be creating a CloudWatch rule, which is basically looking for CloudTrail APIs. So specifically things like delete trail, or stop logging, or update trail. And then I need to define a target, which in this case would be a Lambda function that essentially starts logging when it detects a stop logging event. So I have a Lambda function that I created previously. And this is the Lambda function. So a very simple function. It looks for stop logging, and then it turns around and it starts logging CloudTrail. So let's go ahead and create that rule. Okay, now let's just go to the CloudTrail console, and I'll turn off CloudTrail logging for one of the trails. So you can see that it is currently on. So let me go ahead and turn it off. So let me now refresh the page. So it looks like it is still on. So even though it says it's on, it's not noticeable that something happened, but behind the scenes, CloudWatch Events detected that stop logging event, which in turn triggered a Lambda function to start logging again. But all of that happened so quick that you wouldn't see the difference when you refresh the page. And when you dig into the logs, you would see that the stop logging was there and the Lambda function got triggered. So that's the power of automated compliance, or in this case. Okay. So to summarize, AWS management tools provide you with a suite of services that you can use to enable governance and compliance in your cloud environment. So I highly encourage you to adopt these practices in your environment, as they provide you with the control that you need as an administrator, but at the same time give the agility to your developers to innovate, which is really important for businesses today in a dynamic environment. Here are some of the customers who use the governance strategies that I have just presented in their environment. So really encourage you all to follow these best practices in your environment. That concludes the presentation. Thank you. I'll be around for any question and answers, or if you have any questions, feel free to ask.